Example 9, applying the vertex and x-intercepts of a parabola. A ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation h of t, which is equal to negative 16t squared plus 80t plus 40. In part A, when does the ball reach the maximum height? In step 1, the ball reaches the maximum height at the vertex of the parabola. So we can identify that A is negative 16, and we can see that B represents 80, and then we're going to plug it into the formula for H. So H is going to equal negative 80 over 2 times negative 16, which becomes 80 over 32, and that reduces to 5 over 2. Now, since we want to find the exact height, we're not going to leave it as a fraction since it's an application. So we're going to take 5/2 and rewrite that as a decimal where h is equal to 2.5. So the ball reaches a maximum height after 2.5 seconds. Now, the next question says, what is the maximum height of the ball? So that means in order for us to find the maximum height, we need to find the y-coordinate of the vertex, or k. So what we're going to do is we're going to plug in 2.5 in for h into the function. So we have negative 16 times 2.5 squared plus 80 times 2.5 plus 40, and therefore k is going to equal 140. So the ball reaches a maximum height of 140 feet. In part C, it says, when does the ball hit the ground? So in order to find when the ball hits the ground, we need to determine when the height is 0, where it's h of t is equal to 0. We can use the quadratic formula here. So h of t is equal to negative 16t squared plus 80t plus 40. We know that a is negative 16, b is equal to 80, and c is equal to 40. And then we're going to plug it into the quadratic formula. T is equal to negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times 40 over 2 times negative 16. And so we end up getting t, which is equal to negative 80 plus or minus the square root of 8,960 over negative 32. Now, because the square root does not simplify nicely, we would then use a calculator to approximate the values of the solutions. So let's go ahead and do the first one. If we want to be able to find the solution of the first one, we're going to take negative 80 and then subtract the square root of 8,960. And then we're going to divide that by negative 32. So that gives us approximately 5.458. Now, if we go ahead and do the other one, we're going to take negative 80 and then plus the square root of 8,960 and then divide that by negative 32. We get negative 0.548. So the second answer, the first answer here, not the second answer, the first answer, the second answer, is outside the reasonable domain of our model. So that means we cannot use that one because it gives us a negative time. Okay, we're not going to be able to get a negative time. So therefore, we can conclude that the ball will hit the ground after about 5.48 seconds. So let's take a look at the graph and analyze what we just found. Okay, we can see that it's going to occur at when t, or the time, is 2.5 seconds, and the height, which is the maximum value, at 140, which is what we found. Now, we also wanted to know, when does it hit the ground? Well, it starts here, and so if we say that this represents the ground, well, right here, we determined that the x-coordinate is 5.458, when the y value is 0. So basically this represented the x-intercept of when it would hit the ground. So notice that the graph does not represent the physical path of the ball upward and downward, but it does keep quantities on each axis in mind while interpreting the graph.